Hello everyone, and welcome to our annual update on what's new in the SimCenter Mechanical Simulation Suite, which includes SimCenter 3D, SimCenter Nastran, SimCenter Matimo, SimCenter Tire, SimCenter Magnet, and a new product called SimCenter eMachine Design, which I'll touch upon in just a moment. My name is Simon, and I am not a real person. I am an AI-generated software tool, or a digital twin of a person specially conceived to talk about SimCenter software to you today. Now let's dive right in. Siemens continues to invest in solutions that help you model the complexity of your products, make simulation processes faster, and explore more design possibilities while keeping everything integrated for a streamlined workflow. With those pillars in mind, development highlights for this year are focused on these key themes. Streamlining electric vehicle powertrain development. Integrating physical tests and simulation. Driving design with simulation. Simulating additive manufacturing. Improving automotive safety. Speeding simulation performance. According to the International Energy Agency, over 10 million electric cars were sold in 2022. This accounts for 14% of all new cars, up from just 5% in 2020. To increase EV range, manufacturers continuously look for ways to remove weight. Since axial flux motors can produce a similar performance to radial flux machines but are smaller and lighter, they are an obvious solution. However, it can be harder to dissipate the heat generated by axial flux machines, and accommodating the air gap can be difficult. The complex nature of these machines is challenging R&D departments, many of whom are starting to use simulation tools to reduce development cost and time. With fully integrated simulation tools, you can quickly design and test new motor concepts without ever having to wait for a physical prototype. Optimizing the design of a motor requires the tuning of many components and features, which can make the process complex. Fortunately, with simulation software, we can easily represent these parameters with templates. Until now, Siemens has offered two separate solutions, SimCenter Speed and SimCenter MotorSolve. SimCenter Speed excelled at analytical-based simulations, while SimCenter MotorSolve excelled at FEM-based simulations. Now Siemens introduces SimCenter eMachine Design, which combines the best of both SimCenter Speed and SimCenter MotorSolve into a single modern environment. Additionally, SimCenter eMachine Design gives you the ability to model 5 e-motor types, including axial flux motors. This allows engineers to save significant time in the design process. Additionally, in the early stages of development, analytical-based simulations are suitable for making many types of design choices. However, in the later stages of development, you may wish to consider influences such as leakage flux, eddy currents, thermal degradation, and airflow that require a switch to FEM-based simulations. Electromagnetic forces can significantly impact the structural or acoustic response of an e-powertrain. You can take the electromagnetic forces calculated in SimCenter eMachine Design and then easily transfer them to SimCenter 3D. For example, a common use case for this is to take the loads produced by the motor as output and use it as the input for the powertrain transmission as part of an NVH analysis. The high torque nature of electric motors and the need to reduce weight of the vehicle to increase range introduces a challenge for transmission designers. One method of maintaining gear strength while making them lighter is to employ compound planetary gears, which have a high power density. SimCenter 3D Motion introduces support for compound planetary gears in the transmission builder application. This will allow you to quickly build, model, and simulate the complex geometry of these high-power density EV motor transmissions. Then you can apply this model for further NVH analysis or powertrain optimization simulations to maximize range. Now I'm going to switch to the world of physical testing. That might sound strange to discuss in a presentation about simulation, but bear with me. In order to run a physical test for a product or component, the test subject needs to be fitted with a number of sometimes expensive sensors, such as strain gauges, at key locations. However, what if the part's geometry is complex, or if a critical section that needs to be measured is in a very hard area to reach in the finished product? It can be impossible to get a physical sensor in that location, making it impossible to know if your product will survive critical load cases. This is where simulation can help you measure the unmeasurable. We know finite element analysis can predict stress and strain at any location in the model. But how do you use simulation in a way to predict what is happening at a specific location on a physical part during a real physical test? In this release, SimCenter 3D introduces Smart Virtual Sensing. Smart Virtual Sensing takes the FE model of the product and boils it down to a reduced order model so that it can be run in real time alongside a physical test via a functional mockup unit or FMU. During the test, you outfit your test subject with a few strain gauges in easy-to-reach areas, which then feed information to the Smart Virtual Sensing solver. Based on data coming from the physical strain gauges, the Smart Virtual Sensing solver conducts data fusion between the measurement and model prediction to provide operational loads and virtual sensor status at critical locations with high accuracy. So now you can see results at impossible locations that you never would have been able to measure before. You can also use the operational loads calculated by Smart Virtual Sensing for further types of analysis, such as for durability, so you can better optimize your design. Smart Virtual Sensing provides high estimation accuracy and can compensate for both model inaccuracies and measurement errors. The Smart Virtual Sensor uses Kalman filtering, which is an optimal estimation algorithm for data fusion. The data fusion of measurement and model estimation enables Smart Virtual Sensing results to accommodate for changes in the physical system to automatically self-update estimation. Another highlight of Smart Virtual Sensing is real-time capability. This real-time capable virtual model of your physical structure is what Siemens calls the executable digital twin, and this opens the door to fascinating applications. For example, you can use the XDT during a physical test to reduce instrumentation of physical tests by reducing the number of sensors and the time needed to outfit the test subject or to measure real loads in operational conditions. Additionally, the XDT can live on edge devices on your factory floor to sense when something may need to be adjusted to the manufacturing process to either the machine or part you're producing. Smart Virtual Sensing can also be implemented out in the field for predictive maintenance purposes. In short, Smart Virtual Sensors in SimCenter 3D opens up a whole new world for leveraging simulation models to understand and predict what's happening in the real world in real time. Now you can perform more efficient physical tests, optimize designs faster, make manufacturing smarter, and predict when machines need maintenance. Ultimately, you can maximize the value of the digital twin throughout your entire enterprise. Simulation is no longer just a performance validation tool. And simulation is becoming an organic part of the design process by leading manufacturers to discover and produce new, unimagined design possibilities. Upfront simulation can help designers create better and more robust designs while speeding the overall time it takes to release a design, meaning faster time to market. Upfront simulation is also a tool to improve your communication between designer and engineer. In addition, engineering teams can make use of design space exploration techniques that can automate complex multidiscipline analyses to evaluate and iterate through tens, hundreds, or even thousands of different design variants. This to understand how distinctive design parameters influence product performance, so project leaders can make more informed engineering decisions. Let's start with designers. Traditionally, simulation only happens at defined infrequent steps in the product development process, and it is carried out by CAE specialists working on different software to their design colleagues. This then challenges what should be a collaborative effort between the two worlds and is time-consuming and often not in sync. Analysis tools integrated directly into the designer's workspace can change all that. So this year we introduced a new product called NX Performance Predictor, which designers use to provide design guidance without having to throw it over the wall to the CAE group and wait. NX Performance Predictor works within the NX user interface that designers already use every day and provides immediate feedback on the performance of a part. NX Performance Predictor is based on proven simulation technology from SimCenter Solutions. This shared technology also enables robust scalability with SimCenter 3D when it is time for the simulation team to take deeper analysis and validate the design. With NX Performance Predictor, designers can apply loads and constraints to their part and rapidly simulate a component for linear, static, or natural frequencies analyses. Results are returned almost instantly and can even include a safety factor result type, so designers can assess the risk of their part failing. As a designer makes changes to the design, the simulation results will automatically update for the latest version. This means designers can quickly see how their changes will impact performance. Additionally, due to the tight integration in NX, results from a NX performance predictor can feed into NX product and manufacturing information, or PMI, data, so that can now include performance requirements in the PMI data to help designers monitor and evaluate their design throughout their workflow. Finally, once the part is ready for deeper level evaluation and validation, designers can seamlessly send the part and simulation results to dedicated simulation engineers using SimCenter 3D. Engineers can validate performance and evaluate other aspects of part performance, like durability, for example. We think that access to quick performance feedback within the CAD workspace is a real game-changer. So NX Performance Predictor is available as an add-on to your existing NX software package through either NX or SimCenter 3D value-based token licensing. This means that your design team can get immediate access to this powerful tool right away. Another NX designer-centric tool, NX Topology Optimizer, can help designers, from concept to production, convert functional requirements to a manufacturable part. Based on topology optimization concepts, the solution rapidly delivers the optimal material distribution for the conditions the designer defines. This creates lightweight designs that meet performance requirements and reduce manufacturing cost by replacing complex assemblies with fewer parts. The resultant design, as in an X-native mixed convergent body format, which means the design can work with the resulting geometry right away and can be used for any downstream operations. NX Topology Optimizer has been available for a few years now, and one new exciting feature introduced this year is the ability to define a shape constraint for parts that will be manufactured using CNC 3-axis machining. This new capability allows the designer to account for tool length and tool diameter during optimization to ensure the end geometry result can be created by a CNC machine. Additional manufacturing constraints are available for both additive and subtractive manufacturing processes. Simulation engineers also play a significant role in the design process. For example, you might want to understand how various design parameters could influence the multidiscipline performance of a product. You would need to change various design parameters, update your simulation model, and run the simulation. This is called design space exploration, but to do this manually would be tedious and almost impossible with multiple disconnected design and simulation tools. New this year is SimCenter 3D Design Space Explorer. This new module is integrated natively within the SimCenter 3D environment for end-to-end associativity. What this means is that the design parameters, simulation model, and results are all associated together for the most efficient process. You can easily set up an exploration objective that automatically modifies design parameters, updates the simulation model, and reruns the simulation without needing manual intervention. Now you can run tens to thousands of iterations to evaluate trade-off scenarios or perform design optimization on specific criteria. Additive manufacturing is changing and expanding the types of geometry that you can create for your products. This results in really unique and lightweight designs. However, the process of getting your parts to print correctly can be a costly, time-consuming trial-and-error endeavor. This is because the repetitive localized heat involved with printing metal parts causes the geometry to deform, meaning the shape of your parts isn't matching what you designed in CAD. SimCenter 3D Additive Manufacturing has the ability to simulate the complex additive manufacturing process. It solves the coupled thermomechanical analysis to predict the residual stresses in the part and determines how much the part will deform from the nominal shape you defined in CAD. In this release, SimCenter 3D has improved the compensation method for the advanced powder bed fusion solution to be more robust, faster, and easier to use. This means you can quickly compensate your original geometry to account for the printing process so that your physical print will match your CAD geometry without going through a long trial and error process. By the way, the user interface for managing the print parameters in SimCenter 3D has been improved. Managing larger print parameter datasets is now much easier, and additionally one can exchange print job datasets between different users. When you think of vehicle occupant safety, the first thing that always comes to mind are physical crash test dummies. But beyond this physical testing world, automakers have been using simulation to improve occupant safety for decades. In fact, safety engineers have been using SimCenter Matimo to design and improve advanced passive, active, and integrated safety systems. Because virtual testing of safety scenarios in pre-crash and in-crash events have become essential to improving human protection. Now, with the advent of autonomous vehicles and the potential for new seating positions, the scenarios have multiplied and simulation efforts have increased significantly. And so SimCenter Matimo includes an extensive library of multi-body dummy models. They can be used to assess various crash scenarios as required by regulations around the world to run multiple scenarios in a fraction of the time that it would take using FE-based CAE systems. SimCenter Matimo also includes human body models that are built with a unique musculoskeletal form, guided by a control system of sensors and actuators. This means it simulates a human body reacting to movements while maintaining posture. So far we've talked about the vehicle occupants. But what about the people outside the vehicle, the pedestrians? In this release, SimCenter Matimo has updated pedestrian human body models that are certified to the Euro NCAP TB24 version 4.0 protocol. These models can be used to simulate the effectiveness of deployable pedestrian protection systems. An example of such a system is the active bonnet, or hood, which is deployed when a vehicle senses an imminent impact with a pedestrian and raises the hood to soften the impact, thereby reducing the risk of a severe head injury. So our human body pedestrian model sizes include a 6-year-old child, a 5th percentile female, a 50th percentile male, and a 95th percentile male. As computing power continues to increase, I bet your simulation models continue to grow in size and become more complex. So it is important for today's solvers to keep pace with technology and take advantage of parallel processing whenever possible to help speed up solution times to get the results you need faster. In SimCenter Nastran 2312, our development team has made significant improvement to solution speed of the multi-step nonlinear solution to take advantage of shared memory parallel processing, otherwise known as SMP. In this release, SimCenter Nastran now uses SMP for the internal force calculation with all of the plasticity and/or creep materials. When you request SMP with these materials, solution speed will be 10 to 50% faster, depending on your model. You can run SMP on a single machine with multiple processors and cores, and it does not require a special license. That covers the highlights of what's new in the latest release of the SimCenter Mechanical Simulation Suite. But there are far more enhancements than we can cover here in this session, and I encourage you to view the release notes in the SimCenter mechanical products you're using to see the complete list of new features that will help you model complexity, go faster, explore more possibilities, and stay integrated. I also encourage you to visit the SimCenter blog website, available at the link below, where you can find blogs with even more details on a number of the new capabilities that I just touched upon. I even suggest adding a bookmark to the blog to keep up to date with the latest news regarding all things SimCenter. Another valuable resource for you is the Siemens Support Center, where you can find downloads to the latest software, along with links to the community where you can interact with other SimCenter mechanical product users and experts. It's a great resource to help you get the most value for your unique applications. Support Center also includes technical videos, such as the popular SimCenter TV series that touches on a variety of technical topics in mechanical, CFD, system simulation, and physical testing. Finally, we want to hear from you, our users. Visit g2.com, which is a trusted peer review site for industrial software, and leave a review of SimCenter 3D. Your experience with the software can help guide and inform other engineers to choose the right software that works for them. And thank you to everyone who has left reviews already, giving SimCenter 3D an overall rating of 4.5 out of 5 stars. Again, thank you for your time today. On behalf of the entire SimCenter mechanical team, it's been a pleasure to bring these highlights to you so that you can continue to engineer innovation.